Hello, my name is Ivan Taylor, and I'd like to show you today a presentation that I gave at the annual INCOSE International Symposium in Dublin, Ireland on July 4th, 2024. So I'm just going to play the video, and I hope you enjoy it.
All right, welcome to the second paper of our track here in Leadership 7.6. It is my pleasure to introduce Ivan Taylor, President and Senior Researcher at Policy Dynamics, Inc., with over 3 decades of experience in defense research and development in Canada. He is a PhD in public policy and an MSc in information and systems science, and has been a member of INCOSE since 2020. He serves currently as the Director of Membership and Treasurer for INCOSE Canada. His paper is going to dive into how leadership and cultural transformation can help navigate an organization through adversity, using a real-world case study of an organization struggling with recruitment and retention problems after a series of scandals. So welcome to the next in the series. I know I'm excited about this just from the modeling perspective too of the system dynamics. So take it away, Ivan.
Yeah, thanks, Stephanie, for that introduction. As she said, I'm Ivan Taylor from Waterloo, Canada, and Niamat Hussain is from the University of Arkansas. I do a lot of mentoring of people, and I was a mentor for Niamat. I still am a mentor for Niamat with regards to system dynamics modeling. And I'm going to talk about organizational resilience. This is a paper that I presented to the Resilience Systems Working Group, and I might have expanded it a little bit for this presentation. If you're interested in resilience, I welcome you to join the Resilience Systems Working Group. We have weekly meetings, and once a month we have a mini TED Talk. And there's a lot of great information you can get from the experts in resilience at that meeting. So I'm going to start with introduction, and then I'm going to get into the details of the system dynamics model and its findings. Then I'll have some discussion, and I want to end with some takeaways that I'd like you to get from this presentation. Okay, now resilience is defined generally as ways to avoid, withstand, or recover from an adversity. So generally, I'll be talking about an adversity, which is a series of devastating scandals in an organization, and the recovery, or the attempted recovery, or the plan of how they're going to recover from that adversity. And one of the things that you can see in the resilience sections of the Systems Engineering Handbook and the CBOK is a beautiful schematic diagram of how you can visualize resilience, where we have a capability that suffers an adversity and the capability is degraded, and then gradually over time we recover the capability to a required level. So the idea here is that that resilience is visualized as behavior over time through this picture. And system dynamics modeling, I think, is ideal for looking at resilience because it uses differential calculus and things are modeled as behavior over time. And I'll show you some in this presentation. Basically, you have the variable of interest on the y-axis and time on the x-axis, and you use differential calculus to draw continuous functions that behave over time. So I think it's an ideal tool to look at resilience. And as Stephanie said, we're going to be looking at a case study of an organization that suffered from a series of devastating scandals that ruined their reputation as an inclusive organization. And then that led to to problems with recruiting and retention of employees. And we were working with the client, and they had an idea of a number of policies that could be used to institute culture change. And these policies were all through the entire leadership of the organization. And I'll get into the policies in a few minutes. So, I should have mentioned that there's two types of system dynamics models, if you're not familiar. There's purely qualitative models, which are generally shown as causal loop diagrams. And then there's quantitative models that are generally shown as stock and flow diagrams with equations and parameters. And then there's two types of quantitative models. There's exploratory models which use hypothetical data and just test the assumptions. And I presented a model for resilience of cybersecurity that was a hypothetical model on Tuesday. And then this one is going to be a calibrated model. And a calibrated model uses time series data to try to estimate the parameters for the model from past behavior, and then use that to extrapolate into the future. So this is a calibrated model, and this shows some data that I collected and a fit of the data, which is not necessarily the best fit, but you can see that we normalized the recruiting value to 1 in 2015, and then we can see a series of scandals occurring around 2017, 2018 that led to a reduction in recruiting for a couple of years, and this has been going on then continuously since then. And then we also have a picture of retention, which is even more scattered, but we believe that retention is also becoming a problem, and we have to address it. And of course, there's a connection between recruiting and retention. If you can solve the retention problem, maybe recruiting is not as important. Okay, now we worked with the client, and they came up with 11 policies that they wanted to implement. The first policy, and possibly the most important policy, is a senior leader commitment to change. And so they wanted the senior leadership to set the tone for this culture change. And then the second policy, these are not in order, but the second policy was changing organizational practices, such as the hiring processes and the benefit programs, and then influencing policies, such as introducing flexible work hours. And then there was middle manager professional development, which involved getting middle managers to support teams, and then promoting community, which tried to develop a positive work environment. And then at the employee level, we wanted to strengthen employee skills, which was basically making a commitment to employee growth, personal development. And then another important aspect, again, in the leadership area, is the leadership skills of first-line supervisors. And first-line supervisors are very important for the worker experience. We also had some plans for doing some work on work-life balance and social support networks to improve interactions between people. And of course, there was plans to improve the recruiting program and its quality. And finally, we wanted to impact stressors over time. So these 11 policies were highly interconnected. And that is a real interesting thing that you can do with system dynamics, is you connect the cause and effect relationships. So now, this is a little bit of an unusual way to present the cause and effect relationship. I don't see too many people in the field of system dynamics doing this approach, but I think that there is a certain amount of value in using this technique of a causal structure matrix. And of course, as you may know, system dynamics believes that structure determines behavior. And so we presented the client with this matrix, primarily because they were very familiar as social scientists with correlation matrices. And so we tried to show them how they can think about causation similar to a correlation matrix. And so here we have green squares with a 1 in them representing a positive causation relationship, so that, for example, increasing the leader commitment to change will lead to an increase in the ability to change organizational practices. And then the red squares with the -1 are a reverse situation where, for example, improving leadership skills, first-line supervisors can reduce stressors over time. And the reverse is that reductions in leadership skills of first-line managers will increase the stressors over time. So there's 11 policies on the columns and 11 policies in the rows with recruitment and retention at the bottom and the impact of recruitment and retention. Possibly this might be a little more familiar to you, but it's not a great diagram of the connections between these policies, which you can see looks quite complex in this kind of format. We have the policies around the outside and then recruiting and retention in the middle. I find this kind of picture very hard to read. Then I'll just, one thing that is interesting, I think, is that system dynamics uses calculus, and in particular differential calculus. So we solve the system of first order differential equations by integrating using numerical integration. So these are the equations where Qi at time t represents the quality of policy I. And then what we do is we integrate over t based on a Ci, which is the change in the quality I. And then we have an initial condition. And the change in the quality of policy I is represented by a goal gap model. So basically we have a goal, which is the M, I, and then we have we have a current situation, which is the QI, and then we want to close the gap between the current and the goal, and we do that over time, which is shown here as Y of t. Now the goal is not necessarily just a simple thing. It's actually a more complex formula where actually we have a specific goal in mind for policy I, which is GI, but we have these inhibiting and enhancing relationships represented by the product of these RJIs. And RJI is basically looking back at that causal structure. When RJI is positive or 1, we use this PJ, which is the progress made in quality J in this case. So progress is represented by QJ at time t divided by the initial condition. So but progress doesn't have to be positive; it could be negative. So and so we could have a degradation in the quality of a policy. And then, like I said, when RJI, or when the causal relationship is negative, then we use the value 1 over PJT in the multiplication of the product. So that's some very much detailed description. Here's getting into the results. One of the things that this graph is of course behavior over time, and you can see that we have the historical pattern from 2015 to 2023. And then we introduced the policies in 2023. And we find that actually we have a very interesting dynamic because of the inertia in the system and the difficulty in trying to change culture in an organization. So we end up with an interesting dynamic, which is worse before better. So we introduced the policies in 2023, and you can see that the quality of recruiting actually continues to drop for another 3 years. So in the model, we project that we won't start to see improvements in recruiting until maybe around 2026. And this is a very difficult problem for a leader to appreciate because they're interested in immediate results, and they have difficulty with waiting and persevering and seeing the situation getting worse. But we're trying to use this model to demonstrate that yes, we have to persevere, and we can't expect changes overnight in culture change. So then we start to see a gradual improvement in the model results after 2026, and then it takes quite a number of years to get it back up to the 2015 level. In about 2030, we expect to get back up to the 2015 level, and then we looked at possible long-range futures, and we said that we could have sort of like a best case, expected case, worst case type of model. And in the best case, we might want to enhance or reinforce the policies to get higher than the 2015 levels in recruiting, or we might want to just sustain the policies because they may have a cost factor attached to them, and so they might want to get the results based on investment. And just maintain the 2015 levels in a sustained situation, or we could have a possibly problem if we relax and let the system drop back to its previous type of scenarios and policies and culture, and then we could see a return to the lower levels of recruitment, and then. We have the same sort of pattern for retention. It's not quite as large of a change, but there still is this situation of worse before better, and the three possible trends into the future. Okay, so just as a discussion, I wanted to talk about system dynamics modeling and its strengths and limitations. So as I said, the first strength that we note is that it handles behavior over time, which is really a good way to look at recovering from an adversity. And it uses causal relationships, which we think is of course, a better way to look at nonlinear relationships, whereas correlation and statistics generally are linear. They don't have to be completely linear, but they're generally quite linear. And then the other aspect is that it can handle quantitative and qualitative information. And actually, what we did here is we had basically all the parameters were qualitative, but we turned them into quantitative values between 0 and 1, where 1 was very high quality and 0 was low quality. The limitations are obviously that we had to make assumptions, and those assumptions could be questioned, and we could have had maybe oversimplification, and of course the system dynamics is a continuous modeling technique. So it's very difficult to model discontinuities, and that discontinuities are often created by unforeseen events. In terms of organizational change and culture transformation, we note that these policies could face resistance because there's ingrained norms, and there could be conflicting priorities, as I said, where leadership is impatient and wants to see results faster than they would expect to see because of the inertia in the model. And there could be unintended consequences like some kind of backlash or pushback in the efforts to introduce culture change. So we emphasize that we need sustained effort and patience to actually make culture change or create culture change in an organization. The last thing that is very important is validation. However, in simulation, especially system dynamics, you can never really validate a model. It's impossible to predict the future, as we all know. The best thing we can do is gain confidence that the model is fit for purpose. So some of the things we want to do is, constantly monitor the values of, say, quality of policies for model accuracy, and recognize that these policies, these data points will not completely track the projections, so there's a lot of uncertainty, and we maintain a critical mindset to always question our assumptions and incorporate diverse evidence from a diverse group of experts to validate the model, or at least confirm that the model is working properly, and introduce risk management as much as possible, and try to have continuous improvement in our modeling. Now, despite these challenges, we feel that this system dynamics model is valuable for projecting future scenarios and supporting decision making, we think, as I said, that system dynamics could be a very valuable tool in the resilience systems working group toolkit. The takeaways that I want you to take from this presentation is the ideas that I've already mentioned, but I'm going to emphasize them again, is that leadership is required for organizational resilience and culture change. Leaders must commit to culture change, and I mean leaders here in all the levels of the organization, as I said, from senior leaders, middle managers, and first-line supervisors, all need to commit to culture change, and that the leaders, especially the senior leaders, have to be patient, and the effort has to be sustained for a period of time to overcome the inertia. And basically, there's deeply ingrained beliefs in culture that need to be overcome or changed. In terms of system dynamics modeling, as I said, we think it's effective for studying resilience. It mixes quantitative and qualitative information quite well. It's suitable, for example, to model this idea of leadership on a scale of 0 to 1, where 1 is high quality leadership and 0 is low quality leadership. And of course, you have a gradation between 0 and 1 for the quality of leadership. And of course, one of the great benefits of system dynamics is that you can incorporate delays in the model, and those delays are very good for handling ideas like inertia. In terms of the results, as I said, we have this recruiting and retention problem, and we tried to implement policies starting in 2023. We tried to emphasize to our client that they could expect a worse before better situation, where things might not improve right away, but they should expect to see improvement around 2026 if the policies are retained and sustained. And then it will still take a number of years before they'll get to the 2015 levels, and we projected it would be around 2030. And then after 2030, we were looking at some long-term scenarios for recruiting and retention. Thank you for listening, and I'll take questions.
I didn't even have to get up here before I said, let's go ahead. Can I just check to see if we have any of our virtual audience first? No, then Duncan, please. Go.
Okay, thanks very much. Really good presentation. So did you do any sensitivity analysis on the model? And if so, what did you do?
Yeah, sensitivity analysis can be done. I don't think we did any in particular. Generally, I have difficulty with sensitivity analysis because generally you'll get these wide bands of results as you extend farther into the future. So generally, I think that you can be up or higher or lower. So generally, I like to think of it as, take the expected value. So for example, let's say you did a simulation and ran it 100 times, and then take the average of the results over time and get a confidence band, and that's a very good technique. But generally, I think you'd expect to see the average value with a band of plus or minus, say, some range of values. And we could do that, but we didn't necessarily. I think maybe the way we tried to show it was in these three cases of expected values, a best case and a worst case.
Okay, thank you.
Hello, great presentation. My name is Raquel Valdez. I'm from Sandia National Labs. So I have two questions, but I'll ask the first one. You mentioned delays on your last couple of slides. I feel like organizational structure is very important in this, with like bureaucratic processes and the time it takes to realize a solution and then actually implement it, and that's really important with system dynamics modeling. So can you comment on some of the delays you either implemented or something that you can add?
Yeah, the model took a fairly simple approach to modeling the delays. There's a number of different delay types that are available in the software for system dynamics. We took what's called a first order delay, which is basically an exponential kind of delay or a logarithmic kind of delay, which basically said that, again, we have the goal, and then we have the current situation, and then we try to close the gap between the current and the goal over time. And so the delay is that time it takes to close the gap. And we just did a very simple model of closing the gap, which basically said that you could expect most of the return on investment in the early years. However, if you want to absolutely close the gap, it'll take a very long time. And in fact, it probably would take infinitely many years to get exactly the gap closed.
Great. So my second question, is...
One in the back too.
Sorry. So for the decision maker with the relationship positive and negative for the different organizational motives, did you get those from cognitive insights, or do you see value from stakeholder engagement to maybe add more granularity instead of having +1 and -1?
Yeah,
it can be more continuous.
That's a great question. Generally, like I said, these stakeholders, they generated that matrix. It was their work, so they understood the concept very well from their experience with correlation matrices. However, system dynamics generally talks about 0-1 connections in causation. You don't have half causation or quarter causation. You could have, I guess, priorities, but generally we don't do that in system dynamics. One of the things that I should have mentioned, and it's great that you brought this up, is that we set the model up in a way that the user had complete control over that matrix. So basically, we have an interface for the model showing that matrix. So they can, at any time, switch from positive to negative or switch on something that was turned off at any time and rerun the model very quickly. So we thought this was a great way because to some extent, the stakeholder was still learning about the technique, and they didn't really have a complete understanding of the relationships. So once they understand the relationships better, they can change the model quite easily using the interface.
Let's actually go to the back microphone and we'll alternate.
Heidi Hahn, retired from Los Alamos National Laboratory and now at New Mexico Tech. I have kind of a related question, which is, you said that you translated qualitative variable of quality into quantitative. And so the two parts of the question is, was it just 0, 1? Okay, so it was a graded. How did you define, what methodology did you use to come up with the grading?
Well, we basically used expert opinion from the client. You know, they had a vision of what they wanted to change. They also had a vision of their current state of the situation in their organization. And they had a vision of where they wanted to be in the future. So they recognized that they weren't where they wanted to be, and they were able to do a subjective judgment about where they were today and where they wanted to be in the future. And but it was based on basically expert opinion. We didn't use any, say, statistical techniques to generate those initial conditions.
Thank you.
Hey, Brian Watson, Embry-Riddle Aeronautical University. Really great to see a talk using system dynamics to examine resilience. My question kind of goes back to the beginning. You were talking about some of the limitations and calibration for your model. Given that, and then you're making these recommendations to the clients, how did you convey any uncertainty with your results? Because 2026 is pretty specific, right? So given the limitations on calibration, how did you convey that, and how did the client respond to kind of that framing?
Yeah, I think the client was probably pretty happy that it was going to happen fast. They thought it would take a lot longer. I think the idea that the whole system of when we expect to see results was based on, again, a subjective judgment of how long it was going to take to implement these policies. So we allowed them, again, to vary the amount of time it takes to change the policies for every policy. And so, you know, again, they were given complete freedom. It was full disclosure of all the parameters of the model, and they were allowed to change them at any time and see what the results were going to be. So, you know, we basically just put in constants to start with, to show them how the model would react to change it to a certain set of parameters, but they could change the parameters if they wanted to at any time. So you know, I thought it was a great tool for them to work with. We handed over the tool, and then they could change it and update it with any new information they had as they were going along.
Thank you.
Hi, Paul Davis. I'm retired. I wrote a system dynamics paper for the UK chapter event a few years ago about the evolution of the pandemic, the COVID pandemic. I wanted to ask about, you know, some of the problems I encountered. That system dynamics, as you say, is differential equations and it's basically continuous mathematics. But when you're dealing with individual people, either getting infected or in your case, leaving companies, that's discrete. So certainly in the early days, maybe before they've conducted exit interviews or that they've put the policies in place, it becomes incredibly difficult to model the start of the projection curves forward in time and assigning values to calibrate the model to do with causality. How did you deal with that?
Well, yeah, this organization is huge. So that helped a little bit that we didn't have to get down to the details of individuals. Whenever I come across that kind of problem of working with a small number of agents, I go to agent-based modeling. which I think is almost a direct parallel to system dynamics, and I find it very effective to handle discrete elements in agent-based modeling.
Okay, thank you.
Okay.
So I was going to say, I'm going to ask one,
can ask a
because I can. There's time. So do you have anything that, for this client, you would have asked or recommended as a specific strategy for them to intervene that would change this, given that the complexity of what you're trying to do and the resistance to change when you're talking about these kinds of policies?
Yeah, well, I think, that really highlights the subject of this session, that basically I think that it has to start at the top, and that senior leaders have to set a good example, and then that example has to filter down through all of the leaders in the organization. So if I was going to say one thing that would be most valuable, is basically set a good example for your employees, and then basically walk the talk.
Awesome. Any others? All right, well, thank you, Ivan.
Okay, thanks everybody for the discussion.